Interfaces are like the blueprints for programming. If you overuse them, you'll quickly see the interface hell. But with a pragmatic approach, they can make your code flexible, testable, and easy to understand. For flexibility, imagine an e-commerce application where you want to process payments. You might have a Stripe service, but later, let's say you decide to support PayPal as well. With interfaces, all you would need is another implementation for the IPaymentService. Now that allows you to switch from Stripe to PayPal during runtime. In terms of testing, imagine you have an order service responsible for placing orders. You obviously wouldn't want the order service to call the real Stripe API. What you can do is mock your interface. This allows your tests to be super fast and you can test for specific scenarios, like when the payment is successful or when the payment is declined. You can also leverage interfaces for the decorator design pattern. So if we ever want to add additional logging for only our Stripe service, we can add a logged implementation of the Stripe service. Now during runtime, the implementation can easily be swapped to the decoration library like Scrooter. Finally, let's look at modular code. With interfaces, you can break down complex logic into smaller reusable components. For example, in our e-commerce application, you may have multiple product validation checks, like if a product is in stock or if it's on sale. With interfaces, you can chain these validators together and execute them cleanly and efficiently. In conclusion, interfaces are essential tools for building flexible, testable, and maintainable applications. They make it easy to swap functionality, create testable code, leverage the decorator pattern, and build modular, clean code structures. This has been the mini masterclass on why we need interfaces. If you enjoyed this content and want to see more like it, hit the like and subscribe button. Thanks for watching, and I'll see you in the next one.